Okay, so let's see this question. The bar AB weight 10 kg per meter and it's supported by a cable AC and a pin at B. Reaction at B is taken as. So let's see. This is a bar. Obviously, at this point we have two reactions, that is horizontal reaction and one vertical reaction. Let's say this is RHB and this is RVB. Correct? RVB. But this is vertical reaction and this is horizontal reaction. Is it clear? So you can see here the mass is distributed throughout the length, that is 10 kg per meter. So can I say the whole weight of the body is concentrated at the center, and this is nothing but this is 10 into 10 and obviously into 2 meter. So this becomes 200 Newton force. 200 Newton force which is acting at the center. Yes or no? So let us take, if I take a, and you can see here in this string we have a tension, yes or no, which is looking like this. Let's say this is tension T, then obviously it's here we can get horizontal component. This is T cos 30 degree, and similarly here we can get a vertical component, that is T sin 30 degree. Yes or no? So now for solving this question, what we need to do, first we can write summation of moment about B is equal to 0 because this system is in equilibrium. Yes or no? So the net moment about any point will be 0, and obviously B point is a end point, so moment about that point is equal to 0. So now if you take moment, then can I write this is 10 T sine 30 degree into length is 2 and this is acting in clockwise direction. Yes or no? And minus 2 into, sorry, minus 200, here we have force 200 which is acting at this point, and the distance from B of this point is 1 and this is equal to 0. Yes or no? So from this we can get 200 over 2 sine 30 degree. So this becomes 100 by sine 30, 100 over sine 30, and sine 30 is nothing but this is 1 by 2. So simply we can say T is equal to 200 Newton. Is it clear? So I am getting tension T. Now we need to find out these resultant forces. So how we can determine these resultant forces? So you can see here, let's say, okay, so let's see. For determining of this, can I write summation of horizontal force equal to 0, and from this we can get RHB is nothing but this is equal to T cos 30, and T is already given here, that is 200 cos 30. Yes or no? So RHB is nothing but this is equal to 200 cos 30 degrees. So here I am getting 173.205 Newton. And similarly, if I apply summation of vertical force equal to 0, then can I write this is RVB is equal to 200 Newton. So now here I am getting these two forces, one vertical and one horizontal forces like this. Correct? And the horizontal force is nothing but this is 173.205 Newton, and similarly RVB is nothing but this is 200. Yes, sorry, this is not 200. 200 minus T sine 30. 200 minus T sine 30. Is it clear? So this is equal to 200 minus T is nothing but this is 200. Sine 30 means 1 by 2. So simply here I am getting 100 in Newton force. So our vertical reaction at point V is nothing but this is 100 in Newton. 100 in Newton. So what about the resultant of these two forces? So can I say the resultant is situated somewhere here? Yes or no? And what is the magnitude of this resultant? So resultant is nothing but this is square root of vertical reaction square plus horizontal reaction square. And when you solve this, then you will get 200 vertical reaction is 200 Newton, correct? and now we need to determine their position. So how we determine position? So can I say from about, if this angle is theta from the horizontal, so now can I say here tan theta is nothing but this is 100 Newton over 173.205 Newton, and when you solve this then you will get 30-degree angle. 30-degree angle, yes or no? So now you can see here the resultant force is acting with 200 Newton magnitude and angle 30-degree, and if I see the option, then option B will be the right choice. 200 Newton at 30-degree to the horizontal. Reaction which is acting at the point B is nothing but this is 200 Newton at 30-degree to the horizontal. So option B is the right choice. Okay, so let's see another problem. Four forces of magnitude 20 Newton, 40, 60 and 80 Newtons are acting respectively along the four sides of the square of ABCD as shown in figure. The magnitude of resultant. So you see here this system, since this system is in equilibrium, so can I apply summation of horizontal force, summation of net horizontal force, which is equal to 60 Newton, which is acting towards the left. So let's say it will be taken as negative plus 20. So this is nothing but here we can get for minus 40 Newton. And similarly, if I write summation of net vertical force, then can I say this is 40 minus 80? Then here we can get minus 40 Newton. And if I represent both the forces, so in the coordinate system we can represent like this. This is 40 Newton. Sorry, this is not 40 Newton. This is positive x and this is positive y, but the forces are acting in the negative side. So can I say this is 40 Newton minus, and this is minus 40 Newton. So what about their resultant? So obviously resultant is lying on somewhere here, and this resultant is nothing but this is square root of summation of horizontal force square plus summation of vertical force square. Yes or no? So now if you put these values, so simply here we can get minus 40 whole square plus minus 40 whole square. So after simplifying this we get 40 root 2. 40 root 2 Newton force. 40 root 2 Newton force. So the option A is the right choice. Okay, let's see another problem. This is from trusses example. A two-member truss ABC is configured as shown in the figure. The forces in the member AB. You need to calculate forces acting on the member AB. So let's say this force is AB. Similarly, this force is nothing but this is BC. Yes or no? And let's say if in this we have an angle theta. So can I say this tan theta is nothing but perpendicular which we have 0.5 meter. So 0.5 over 1, or simply you can say 1 by 2. So if I make a triangle like this, and if this angle is theta, so can I say 1 is here and 2 is here. So the hypotenuse is nothing but this is square root of 5, square root 2 square plus 1, that is root of 5. So from this can I say tan sin theta is nothing but it can be written as 1 root 5, and similarly cos theta is nothing but it can be written as 2 root 5. Yes or no? Okay, so now if I apply method of joint at point B, method of joint at B, then can I say here we have these forces, yes or no? And this angle is theta, and this is 10 kilonewton force, yes or no? And this is FAB, and this is FABC. So when you resolve this FBC force and write summation of horizontal force equal to 0, then you will get FAB plus FBC cos theta is equal to 0. So from this FAB can be written as minus of FBC cos theta. Yes or no? Let's say this is equation 1. Similarly, we can apply summation of vertical force equal to 0. So can I say FBC sin theta plus 10 is equal to 0, means FBC is nothing but this is minus 10 over sin theta. Is it clear? And what about sin theta? Yes, so here we know that sine theta is nothing but this is 1 by root 5. So can I say this divided by 1 root 5? So simply here we can get minus 10 root 5. Yes or no? And once you get FBC, now you just put this value in equation 1 from equation 1. So can I say FAB is nothing but minus of FBC. This is minus 10 root 5 and cos theta, and instead of cos theta can I write this is 2 by root 5. So this is cancel out. So from this here we can get FBC is equal to 20 kilonewton. FBC is nothing but, here I am writing, you can see FBC is nothing but this is 20 kilonewton. Is it clear? 20 kilonewton. So option C is the right choice. Option C is the right choice. Is it clear? Option C is the right choice. Option C is the right choice. Okay. So let's see another problem. You can say here, two equal forces are acting at a point with an angle 60 degree between them. Two equal forces are acting which makes an angle 60 degree. Yes or no? Let's say this force is F and this force is also F. If the resultant of forces equal to 60 root 3, if I say this is resultant which is equal to 60 root 3, what is the magnitude of each forces? What is the magnitude of each forces? So can I say resultant is equal to square root of, since both the forces are equal, so can I write this expression F square plus 2 times of F into cos 60 degree? Yes or no? So simply here we can get square root of 2 times of F square plus 2 times of F square cos 60. And now if you take F as a common term, so here we can get 2 times 1 plus cos 60. Is it clear? So this is nothing but this is square root of 2 into 1 plus, what about cos 60? This is 1 by 2. So when you simplify this, then you will get F is equal to, this is 3 by 2, 2 is cancelled out, so here we can get root 3. And what about R? This is already given here, 60 root 3, this is equal to F root 3. So from this here we can get F is equal to 60, and there is no unit, so leave it. So here we can get 60. So the correct option is option D. Okay, let's see another question. 10 kg mass is hanged with from two light inextensible string. So yes, here the figure is missing. So here I am going to draw. This is the mass which is hanged with these two strings. This is string 1 and this is horizontal string. Is it clear? And you can see here this string makes an angle 60 degree. So 10 kg mass, so obviously its weight is acting in downward. Let's say this is 10 into 10. So this is equal to 100 Newton. Correct? The tension in the horizontal string. So if I draw a free body diagram, so can I say here we can get this kind of free body diagram. This is 100 Newton force and this is horizontal tension and this is tension induced in inclined string. Yes or no? So let's say it is represented by Ti. And obviously if it makes an angle 60 degree, so simply this angle will be 30 degree. Yes or no? And if this angle is 30 degree, so can I say this is equal to 120 degree, and if this is 120 then this will be 150 and this is 90 degree. So simply you apply Lami's theorem to solve this question. Lami's theorem, and if I apply Lami's theorem, so can I say TH, which is TH over sine 150 is equal to 100 over sine 120. So from this can I say TH is nothing but this is sine 150 over sine 120 into 100. Yes or no? And when you solve this, then you will get, you can see a sine 150 over sine 120 into 100. So simply here we can get 57.735 kilonewton. Sorry, not kilonewton, this is Newton. So the option B is the right choice for this question. Okay, so what about this? A body A of weight 10 kg with its CG 25 centimeter. Let's see. Here I am going to draw a figure. This is the axis of rotation. At this end, we have one mass whose weight is 10 kg. So its gravitational force is acting like this, 10 into 10, which is 100 Newton. And its centroid is situated at a distance from the axis of rotation is 25 centimeter. Correct? Balanced by another weight of body B of weight 5 kg. So let's say here we have 5 kg weight. So can I say this is 5 into 10, which is 50 Newton force. And let's say if it is situated by an x distance, so you need to calculate this x. So can I balance this system by a moment? So you just take moment, summation of moment about axis is always equal to 0. So simply here we can say 100 into 25 is equal to 50 into x. So when you simplify this, then you will get 100 into 25 over 50. So simply here you can get x is equal to 50 centimeter. Means if you place mass B at a distance of 50 centimeter, then definitely you balance this mass system. Yes or no? Okay, so let's see another question. Tension in the cable supporting a lift of weight W and having an acceleration. You can see this is a lift whose weight is acting W, and tension in the cable supporting. You can see here we have tension T, and this is a cable, and W having an acceleration of while going upward. Yes, this lift is moving upward. So let's say acceleration is taken in the upward direction. Correct. So how much tension exists? So can I say this is T minus W, which is equal to mass into acceleration. So T is nothing but this is W plus MA. And what about W? W is nothing but this is mg. So what about M? It can be written as W by G. Yes or no? So simply can I say if I replace this is W and instead of mass can I write W by G into A? So simply here you can get W into 1 plus A by G. W into 1 plus A by G. W into A plus 1 by G. Option A is the right option. Correct? Okay, let's see another problem. Again from truss, and this is very similar question which will ask in the GATE exam also. So you can see a mass of 35 kg is suspended from the weightless bar AB. This AB bar is a weightless which is supported by a cable. CB is a cable. At a point at A as shown in the figure, the pin reaction at A. You can see here we have vertical reaction that is RH, and here we have horizontal reaction that is RB. Is it clear? And at the end here we have a mass M. So if I apply a method of joint for B, for joint B, so can I say here we have one tension, here we have another tension, and here we have weight which is equal to 35 Newton, 35 kg. So let's say if I multiply with 10, then here we can get 315 Newton, and here we have tension T, and here we have force BA. Yes or no? And what about angle? So if I say this angle is theta, so what about tan theta? So can I say tan theta is nothing but this is 125 over 275, and simply if you divide with 25, then here we can get 5 over 11. Is it clear? 5 over 11. So if I represent this, let's say this is theta and this is 5 and this is 11. So can I write this is 25 plus 121, which is nothing but this is square root of 146. So from this can I say sine theta is nothing but this is equal to 5 over square root of 146, and cos theta is nothing but this is 11 over square root of 146. Correct? So let's say this angle is theta. So can I say P has two components, one is vertical and one is horizontal. So if I write summation of vertical forces equal to 0, so simply we can say P, simply we can say P sin theta is equal to 350. So what about T? So 350 over sin theta, and as you know that sin theta is nothing but, here we have 5 by 146 is 5 into square root of 146. So from this here we can get 350 into square root of 146 divided by 5. So simply here we can get 845.81 Newton. Yes or no? And after getting tension T, so can I say if I apply summation of horizontal force equal to 0, so FBA is equal to minus of T cos theta. And obviously here we have 845.81 into cos theta is nothing but this is 11 over 146. Correct? So instead of writing this, can I write this is 350 into root of 146 over 5. So this term is cancelled out with this. So simply here we can get 11 over 5 into 350. So this is 770 Newton. 770 Newton. This is nothing but this is FBA with negative sign. Yes or no? So this is FBA. So we need the pin reaction at A. Actually, we need to find out reaction at A. So now for the determination of reaction, simply can I say if I apply summation of vertical force is equal to 0, summation of vertical force is equal to 0. So this is nothing but this is RV. RV equal to T sin theta minus mg. And T sin theta we know that which is equal to 350. And what about yes, what about mg? This is 350. So this is equal to 0. Next, if I write summation of vertical force equal to 0, then can I say this is RH RH is equal to T cos theta. T cos theta. So what about T? This is 845.81 into cos theta. Can I say this is 11 over square root of 146? So simply here we can get 769 or 770 Newton. 770 Newton. So horizontal reaction we have 770 and vertical reaction we have 0. Correct. So the option D will be the right choice. Why here we have 755? Because if you use G is equal to 9.81, then you definitely will get this value instead of 770. Is it clear? But in this I am using 10, that's why I am getting 770. So don't worry about this.